Hello, physical science class. This is a copy of the chapter 16-17 test, and as I emailed some of you, there were some questions and struggles on some of it, so what I want to do is start fresh with a blank copy and walk you through it a little bit, pointing out some important things that I wish we could have reviewed if we had taken the test. After you watch this video, I would like for you to go ahead and try to correct for yourself your own test and then resubmit it to me, and I'll give you a changed grade. So I just want to start off with our multiple choice questions, right? I want to remind you that a proton is abbreviated by a capital P, a neutron abbreviated by an N, and an electron abbreviated by an E. One of the things that I want to remind you of at this point is the fact that in order for a identification of an element, when you look at a periodic table of elements, the proton number is the same thing as the atomic number. That's how you identify an element, right? So for example, boron, B, on this periodic table, how you identify it is by its atomic number, 5, right? That's how 1, 2, 3, 4, 5, that's its identity, right? Where it is on the periodic table. So boron 5 means that it has 5 protons. If it has 5 protons and it's neutral, it must, because protons are positive, also have 5 electrons. And 5 electrons would be 5 negative charges, right? Positives and negatives cancel each other out, so boron would be neutral on this periodic table. The other thing that I want to point out to you is the mass number. In this case, they did not do, they have it out in a decimal form, very, I don't know, nitpicky in detail. When you look at mass number, I want you to think protons plus neutrons. That's what makes up the mass of this atom. So in this case, we would look at our chart here and notice that 10.8 could be rounded to 11. 11 is our whole number. That's our protons plus neutrons. If we wanted to calculate how many neutrons, we would take 11, which is protons plus neutrons, and subtract out 5, which is our number of protons, right? If you have protons plus neutrons equaling 11, and you subtract out 5, that would give you the number of neutrons that are present, 6, right? Because 5 plus 6 makes 11. So I want to just have you remember what is positive, what is negative, and what are uncharged found in the nucleus, and what then is the atomic number. So keep those things in mind as you are matching up those choices there. Okay, when you think of neutral, I want you to think no charge, right? What has no charge? Some of the things have positive charges, some have negative charges, some have no charge. They're going to all add up to equal your atom, okay? I want to also remind you, as you're looking at your periodic table, that this whole section this whole section are metals. This section over here are the nonmetals, and this stair step is your the kinds that we would call what's the word I'm trying to think of? Oh, I should have paid more attention to this before I said it. These are going to be those that are what we would call semi-metals. They act like metals in some cases, but they're not true metals, nor are they non-metals, right? They're the things that are used in our electronics because they're semi-metals. They're kind of a special case, right? So non-metals, semi-metals, metals, right? I also would like to point out that when we talk about identifying an atom, that's kind of like for you what your social security number is. You have a social security number that identifies you, right? When you grow up and have to do taxes, your social security number is what identifies you. So I want you to think about that in terms of the proton number on the periodic table, right? That's what makes krypton different from lithium, right? That's the identity of those elements, okay? On the second page, I want you to tell me, this is 11 through 13. That means this is question number 11. This is 12. And this is 13. Tell me what is the number of protons, what is the number of neutrons, what is the number of electrons for PB 20782, right? So in other words, I want you to tell me how many protons does lead have, how many neutrons does lead have, and how many electrons does lead have. Okay? I don't want to do these particular ones for you because I want you to be able to correct them. So I'm going to pick something different, okay? I'm going to pick neon, okay? So neon is on my periodic table over here. I'm going to write it kind of like you have yours. Okay? So when you look at this, I want you to see that neon's setup is this, okay? This is what identifies my element, right? That's the number of protons. That's how I can find it on my periodic table, right? 10 neon. So 10, my number of protons, this number, remember, is my atomic mass. My mass is my protons plus my neutrons, okay? So in order to figure out how many neutrons, I'm going to subtract my mass number minus my atomic number, and I'm going to say 20 minus 10 gives me 10. That 10 is my number of neutrons, okay? So it's not always going to work out this way. It just happens to work out this way in the one that I'm doing. Yours obviously is not going to have the same number for each of these. I'm doing it differently. You're just going to use the same kind of scenario. I want you to also remember that protons being positively charged are going to balance out with my electrons, which are negatively charged. So if I have a neutron element, or a neutral element like neon, then it's going to have an equal number of protons and electrons, okay? So that being said, I want you to use that kind of information. Each one of these are going to tell you something that you have to do. And again, this one has 3 parts as well, 14, 15, and 16. Down here, I want you to remember that valence electrons are not my total number of electrons. They're only the outermost shell of electrons. Okay? And how you determine that is by looking at 1A, 2A. We're going to skip over the transition metals because they all have only 1 or 2. 3A, 4A, 5A, 6A, 7A, 8A, right? 1A is going to have 1 valence electron. 2A has 2. 3A has 3. 4A has 4. 5A has 5. 6A has 6. 7A has 7. 8A has 8, right? So when you look at this and it asks you to give the number of valence electrons in ground state, look at potassium, look at sulfur, look at oxygen on your periodic table. Look where they are in the column, and that's going to be how you're going to tell how many valence electrons that element has. Okay? So I would like for you to try redoing this page, and you're welcome to redo any of the other rest of your test, including the ones that we already went over on the first page, and then try resubmitting it so that I can grade it again. Let me know if this makes sense. I'm going to post it on our classes page, and I'll send you the link. Bye.